Greetings everyone, this is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of What to Look For in the Night Sky, January 8th, 2024, this time around. So last week, we talked about geometry, we talked about perihelion passage and why the days, we talked about the daylight having gotten longer in the evening for quite a while, and we're just now turning the corner to the daylight, getting more daylight in the spring for those of us here at mid-northern latitudes. So anyway, I enjoyed talking about that geometry so much, I thought we would do it again a little bit this week. Maybe I was the only one who enjoyed it, but I thought it was great. So we think about, let's think about the coordinates we measure stars on the sky with. We have these longitude lines that span the globe, and we can identify, we have latitude lines that go around the globe this way. And we can identify any position on Earth by a longitude and a latitude. A longitude tells you how east-west you are relative to some arbitrary zero, and the latitude tells you how north-south you are relative to some zero that we usually would set as the equator. If you project those onto the sky, the stars will then have a similar coordinate system that will tell you exactly where they are on the sky. And the stars move a little bit, but they don't move very much. So we can treat those coordinates as sort of fixed with the stars, and we call the longitude lines projected onto the sky right ascension, and we call the latitude lines projected onto the sky declination. So we look at those things and we say, there's a right ascension and declination of these stars are fixed, and we can identify a star with right ascension and declination that way. Now, I live at 43 degrees north latitude, and at 43 degrees north latitude, that means I project that directly on the sky above me. That means declination of plus 43 degrees would be the objects that can be directly overhead. Great? So I see these objects that can be directly overhead at plus 43 degrees. And then, if I put a ruler, a yardstick on here like this for me, what I can see, that's my horizon. I can see the sky 43 degrees, down 90 degrees this direction, and down 90 degrees this direction. If I go down 90 degrees this direction, 43 degrees minus 90 degrees suggests I would be able to see objects all the way down to negative 47 degrees of declination. But I know I can't because of local horizon effects, because of hills and trees and buildings and thick atmosphere to look through. I have a hard time seeing down below negative 20 or 30. Stuff has to be pretty bright for me to be able to see that. When I look to the north, this direction, the projection of the North Pole is up here. That's the North Celestial Pole. That's the North Star. Anything that's within that cone of what I can see, that cone surrounding the North Star, I'm going to be able to see all the time, and we say it's circumpolar. So I look to the north, and I see the stars executing circles around the North Star that look like that. Bigger and bigger circles the further and further you get away. And as I get below, there's the North Star has a declination of plus 90. As I get down here, I can say, that's 47 plus 90 degrees, 43, excuse me, plus 90 degrees gets me up to 90, and then I have 47 degrees back down, 43 degrees back down the other direction. So anything's within 43 degrees of the pole here. If that angle's within 43 degrees, I can see it all the time. Again, my horizon makes a big effect. I've got hills and trees and buildings and light pollution and stuff like that. And so I can't see all things all the way. But it tells me that anything with a declination of about 47 or above would be circumpolar for me, and I would see these complete circles. Otherwise, I see the stars rising up in the east and moving across. I see parts of the circles and setting in the west. As I look further and further south, close to that negative, closer and closer and closer to that negative 47 degrees theoretical declination that I could see down to, I see smaller and smaller fractions of the circles. And so they're in the sky for less time, and I barely see them above the horizon down there. As I just see a partial bit of the circle. They're not really semicircles, but they're partial bits of the circle like that that I'm seeing looking to the south. So this is north for me, and this is south. Again, not really half circles, but fractions of circles like that I'm seeing down that direction. Just a small, you can think of this circle continuing down under the horizon over here, but that's my horizon line that I can't see below. So let's put that in practice for observing this week for me. So for me, I think I get things with declination about 47 degrees, I'm sorry, about 43 degrees directly overhead for me. This time of year, that means I'm looking in the direction of Auriga often. So this is the constellation Auriga, and that's Capella is the big bright star in Auriga, and it has a declination of about plus 46. The beta star, Menkalinon in Auriga, that's the alpha star. The beta star has a declination of about plus 44. So it's really close. It's within a degree or so of directly overhead at the right time. And the right time for me right now is about 11:15 p.m. Stars rise 4 minutes earlier each day, related to what we talked about last week. So 11 to 11:30 in the week ahead would be a good way to think about this. Or 10:45 to 11, about 11. Let's just say around 11 o'clock. Menkalinon is going to be more or less directly overhead. So when I go outside at 8 o'clock, I'm going to see it east of directly overhead. The big bright star I see is Capella, and I see this sort of diamond shape of Auriga like that. When we look at the diamond shape of Auriga, we connect these bottom part of the diamond, the path. We've got three beautiful open star clusters in there, M38, M36, and M37, that straddle that line that connects these stars down here below Capella and Menkalinon. So go out, you got your small telescope, maybe even your binoculars probably will do this job. See if you can identify those open star clusters. Find Capella, find Menkalinon. For me, I don't know where you're observing, but for me, recognize that this is more or less directly overhead at about 11 o'clock. In the week that we're talking about. Now, if we go north from there, Capella is right on the edge of being theoretically circumpolar in the sky where I can see it all the time. Now, it's not really anywhere close because it's cut off down in here, and it's right on that edge anyway. So I go north just a little ways, and so if I go north about the width of this diamond of Auriga, I go north, and I get another sort of kite shape or diamond shape of stars, but these are much fainter. These are sort of fourth magnitude stars. And the alpha star and the beta star that we have up here in Lynx. And so we're talking about Lynx up this direction, and this is a group of stars we often don't talk about very much. And so see if we can identify these stars. These stars are far enough north for me now. So here's the thing about this region of Auriga, is that it's about 5 hours of right ascension, the projection of longitude on the sky. This is also about 5 hours of right ascension, but far enough north that these stars really genuinely are circumpolar for me. The issue is they're all fourth magnitude stars, so you got to work to see them, but there aren't a lot of bright stars between here and there. So you just go north, take the pattern of Auriga and just transpose it to the north, about the same size, like this, move about the one distance, boom, boom, and then you'll see this pattern of Lynx that's up there in the north, and see if you can identify some of these stars. There's a decent open star cluster, again, along the bottom edge of the pattern of stars. You might be able to find NGC 1502. Get your small telescope out, look for another open star cluster, NGC 1502, and see what you can do. Now, if we go the other direction, we stay at 5 hours of right ascension, more or less. What's directly overhead, what's on the meridian line for me that connects north to south overhead at about 11 o'clock at night. But we go to the south here, and we'll have to cross through Orion. Maybe the pattern of Orion is familiar to you with the three stars in the belt and the shoulder stars and the leg stars. But we keep dropping to the south, and we make about that distance again to the south, and the brightest star we come to is our Neb. And that's the alpha star in Lepus. And Lepus has make a sort of cross of stars, a diamond shape of stars around our Neb in the center. And you see these stars. Our Neb's a brighter star than anything you're going to see in Lynx. So Lepus is a brighter constellation than Lynx. But now we're getting far enough to the south that I'm seeing just part of this, not in the sky very long, part of this arc for me. And if I really want to push this, I'm going to drop all the way down from our Neb in the center of Lepus, down about, go to Nihal is the next star you come to the south. Go that distance again or so, and we've got a globular star cluster, M79. Now that really is, that only ever gets above 11 o'clock tonight. Again, 5 hours of right ascension here. So about 11 o'clock is when it's going to be in the highest in the sky for me. But at about 11 o'clock right now, that's only going to be maybe 20 degrees above the southern horizon for me. and 20 degrees above the southern horizon means, hey, I better not have any trees that are hills that get up that high, and I better have pretty clear, clean skies looking that direction to see something fuzzy. But this is a good test object for me. Can I see M79 on any given night? Can I actually see far enough to the south to make this work? I have the advantage here of being able to get up on the science building. So when I'm up high on the science building, I can see down to the horizon quite a bit better. So M79 will work for me, but again, I'm thinking about looking north to see Lynx, and looking south to see Lepus, and looking directly overhead to see Auriga. Now, while you're looking at Lepus to the south, the Gamma star in Lepus, so you've got your sort of diamond shape right there, the cross that goes through the middle with our neb, and then dangling off the Gamma star, dangling off the left part of that cross right there, is a really fine double star. So you got your telescope out, really widely separated, in interesting colors too. So you've got your telescope out to look for things like these star clusters that we've been looking at. Go ahead and check out the Gamma star in Lepus and see this really fine binary. So an actual binary star, pretty close, but it's so close they're pretty widely separated. Close to 1,000 astronomical units. One astronomical unit separates the Earth and the Sun, and so these two stars are separated by 900 or 1,000 times the separation of the Earth and the Sun. And you can see them. It's a fun thing to check out. 5 hours of right ascension, north to south. Good stuff to see this week. As always, everybody, thanks for watching. Hope you have a good week of observing ahead.